When installing electrical circuits, understanding the National Electrical Code, specifically Article 110.3b and Table 310.16, is essential. Let's break down how to correctly size conductors for an appliance circuit, such as a 2000-watt, 120-volt water heater. Firstly, the standard rule, as outlined in Article 110.3b, requires that conductors be sized to handle 125% of the continuous load. To calculate the continuous load of the water heater, we divide the wattage by the voltage. In this case, 2000 watts divided by 120 volts equals 16.67 amps. Next, we apply the 125% rule to this continuous load. That is, 16.67 amps multiplied by 1.25 equals 20.83 amps. Based purely on this calculation, it would appear that a conductor capable of handling at least 20.83 amps is required. Now, let's consider Table 310.16, which provides the allowable ampacities of insulated conductors. This table shows the maximum current, in amps, that different sizes of copper and aluminum conductors can carry safely, based on their insulation type and ambient temperature. It's important to select the correct temperature rating column from the table. Common temperature ratings are 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. The choice depends on the terminals and equipment you're connecting to and the insulation rating of the wire you are using. For example, if the terminals are rated for 75 degrees Celsius, you must use the 75 degrees Celsius column, even if the wire insulation is rated for 90 degrees Celsius. Typically, for residential wiring, the 60 degrees Celsius or 75 degrees Celsius columns are used. In our scenario, the answer references the 60 degrees Celsius column, which is important to consider. Now, let's say we are looking at the 60 degrees Celsius column in Table 310.16. For a number 12 American wire gauge copper conductor, this column typically shows an ampacity of 25 amps. For a number 10 American wire gauge copper conductor, it usually shows an ampacity of 30 amps. Going back to our initial calculation, we determined that the continuous load, plus the 125% factor, was 20.83 amps. This value is less than the 25 amp rating of a number 12 wire in the 60 degrees Celsius column. So, at first glance, it would seem like a number 12 wire would be acceptable. However, without the exception, Article 240.4d would require a number 10 wire. Article 240.4d of the National Electrical Code deals with the protection of conductors against overcurrent. It generally requires that overcurrent protection devices, such as circuit breakers or fuses, be sized to protect conductors at their ampacity rating. Without the exception, this means you would need to choose an overcurrent protection device that is rated at or below the ampacity of the conductor. So, if you were using a number 12 wire with an ampacity of 25 amps, you would typically need a 25 amp or smaller circuit breaker. However, Article 240.4d places restrictions on using overcurrent protection devices that are larger than the conductor's ampacity, especially for certain small conductor sizes, like number 14, number 12, and number 10 American wire gauge. This rule is in place to prevent the conductors from being subjected to currents that exceed their safe carrying capacity, which could lead to overheating and potential fire hazards. Here's where the exception comes into play. The note below Table 310.16 references Article 240.4d and states that the requirements of Article 240.4d do not apply to appliance branch circuits installed in accordance with Article 422. This is a critical point. Article 422 covers appliances. This means that for appliance circuits, you are not necessarily required to use an overcurrent protection device that is rated at or below the conductor's ampacity. Instead, the overcurrent protection is determined by the appliance itself, as stated on its nameplate or in its instructions. In the case of our 2000-watt, 120-volt water heater, the nameplate provides the electrical characteristics of the appliance. The water heater is designed to operate at 2000 watts and the circuit should be protected accordingly. Since the continuous load is 16.67 amps, and the 125% factor brings it to 20.83 amps, a number 12 wire, which has an ampacity of 25 amps in the 60 degrees Celsius column, can be used. The overcurrent protection device, such as a circuit breaker, should be sized to protect the water heater, not necessarily the conductor. Typically, a 20 amp circuit breaker would be appropriate in this case, as it is close to the calculated load of 20.83 amps but does not exceed the ampacity of the number 12 wire. It's important to note that local codes and regulations may have additional requirements or restrictions, so it's always a good idea to consult with a qualified electrician or electrical inspector to ensure compliance. Now let's summarize the key points. Firstly, calculate the continuous load of the appliance by dividing the wattage by the voltage. Secondly, apply the 125% rule to the continuous load. Thirdly, consult Table 310.16 to determine the allowable ampacity of different conductor sizes. Fourthly, be aware of Article 240.4d and its restrictions on overcurrent protection for small conductors. Fifthly, understand the exception for appliance circuits, which allows for the use of smaller conductors based on the appliance's requirements. Sixthly, size the overcurrent protection device to protect the appliance, not necessarily the conductor. Finally, always consult with a qualified electrician or electrical inspector to ensure compliance with local codes and regulations. In this specific scenario, a number 12 wire would be acceptable for the 2000 watt, 120 volt water heater circuit, provided that the overcurrent protection device is properly sized to protect the water heater itself. Remember to always prioritize safety and follow all applicable codes and regulations when installing electrical circuits. The code exists to protect the public. Improperly installed electrical wiring can cause significant property damage or loss of life.